When should we use recursion? This is the rule that I like to use. When it gets to complicated problems like traversing or searching through trees or graphs, something that we're going to talk about with breadth first search and depth first search, recursion is really useful and better than iterative approaches. And with sorting through items, there's also cases that we'll see that recursion is preferred. And when it comes to recursion, these are the rules that I like to follow. Every time we're using a tree or converting something into a tree, consider recursion. And there's 3 key things in an interview question that might trigger a recursive solution. One is that a problem can be divided into a number of subproblems that are smaller instances of that same problem, such as the exercises we've done with Fibonacci numbers or factorial. We can break those down into little trees that break down to smaller and smaller pieces. Those are inherently recursive problems. Another factor is that each of these instances of subproblem is identical in nature. That is, the calculations that we need to do are pretty much the same. They may be smaller values, but the actual calculations underneath it is all the same over and over and over. And then finally, the third point is that those solutions, if you solve the smaller problems, the leaf nodes of that tree, and you combine them, that solves the problem at hand, then that is a recursive solution that you can use. And you'll see a lot of divide and conquer using recursion. Remember divide and conquer, which we mentioned when we got to the tree data structure lessons. It's kind of like looking through a phone book. When you're looking for Bill in the phone book, you're not going to start from A and simply go one page at a time from left to right. No, you usually split the phone book in the middle or try to go to the B section of the phone book and start dividing up the problem page by page until you get closer and closer. This divide and conquer type of questions usually have recursion in them. And as we know, the one thing that recursions can do that looping can't is that they can make tasks super easy, such as these types of problems. As a matter of fact, I encourage you to write your own traverse function that we used in our tree data structure. This is something that we're going to get to when we get to searching in the algorithm section. But if you want to challenge yourself, see if you can write a traverse function like I did over here using recursion. And then also try to write it with loops. You'll see that with loops, things like tree traversal is a headache. I can't even do it from the top of my head. With recursion, it's pretty straightforward. With loops, you usually have to maintain some sort of a stack to keep track of things, and it really adds a lot of complexity. So use the rules below to notice when a recursive problem presents itself during an interview. I'll leave a few more exercises for you after this video. But as we'll see, we'll come back to this topic when we get into other algorithm sections. And things will start to get clearer and clearer. I'll see you in the next one. Bye-bye.